our latency table. So I'm going to grab my entire latency table here. I'm going to do Shift asterisk and type in 1.2. I'm going to add 20% to this. If we jump back in here to fuel, notice here that we're extremely rich right now, as we're finding it's 70s lambda, 80 lambda, or now we're taking 20% out. Now notice the warm-up enrichment here, as we're running, it's still adding 25% back in. Now notice, lambda correction here, the lambda correction is taking out a certain percentage of fuel. The lambda here is following suit to whatever that correction is showing us. So these two are relatively close, 92 lambda, 90 lambda is the target, and where actual is pretty close to that, and the correction is making up for that. So it's still taking out a bit of fuel. Now, at this point, the engine is idling. So I'm going to let it warm up. I'm not going to make any more changes. Again, I just wanted to do that quick change to the dead time values to fix that fuel modeling, because what we're going to find here is that this warm-up enrichment, as this goes away to 0, this correction is going to go probably and add some back in, because this is accounting for that warm-up enrichment, accounting for offsetting any kind of atomization or poor atomization of the injector as it's spraying into the engine as it's cold. So as this warms up, as this goes to 0, we're probably going to have to fix this further. But again, what I'm going to do right now is just let it run, let it start to smooth itself out. Once it gets up to operating temperature, then we'll pick back up here, take a look at our idle control, take a look at our fuel modeling here, see how far we're off by. We still have a whole lot to go here, but we have just kind of a rough in getting the engine to fire up and run. So we're getting there, but we still need to go and do a couple more things to make sure this is 100%. Let's let it come up to operating temperature, and then we'll check everything out and take a look at the data log and see where we end up at here in terms of the control and in terms of what other adjustments we need to make on the fuel side of things to correct our deviations or the error that we're finding right now. All right, so we can take a look here where coolant temp is about 145 and the warm-up enrichment has zeroed out. At this point, the post-start's gone and the warm-up enrichment gone. Now, both of those will add on to the main fuel table calculation for injector pulse width. So now we're riding just on the main fuel table. So now we can expose what's going on here. Now, a couple things I want to talk about real quick. We can see here that the engine speed is only 700, 800, maybe 900. We want the engine idle to idle at right around 1,050 to 1,100 with these big injectors. We can't idle at low RPM because the injector is not going to perform in a linear manner. So some of what we're finding here between the target and the actual, we see it's bouncing around a little bit here, and the closed loop correction is moving slowly to try to add some fuel in. We're finding that the discrepancies that we're seeing here are likely a result, the actual air fuel bouncing around is like a result of the RPM being too low. Let's jump into the idle controller quick. Let's get that sorted out. Jump in here to idle, and let's take a look. So we can see right now that the idle target should be 1,136, let's say, 1,135. We see we're at 800. The air here is about 300 RPMs off. The ignition angle is actually showing 30 degrees, so it's adding a whole bunch of ignition timing at idle specifically to try to bring the idle torque up to be able to get the idle speed up. Now, in this case, we see that the idle control output here in this open loop type format, this is what's sent to the idle control motor. The idle control motor is regulating how much airflow is coming into the engine. We need at this point more idle torque. We have added a whole bunch more spark timing, and that's not getting our idle torque to go up or idle speed to go up. So if we're increasing the torque, we're increasing our idle speed, we're increasing where we want to go to the idle target. We need to go in here and either go after the airflow or the spark timing. We've already seen the spark timing is capped out here. 30 degrees is the highest that it can add here. As we're seeing, 30 degrees is the highest it can add. So what we need to do is increase the pulse width that's going to be sent out to the idle control motor to increase the airflow. The airflow is a coarse adjustment to the idle torque. The spark timing is more a fine adjustment. Let's go in here and just raise this up here. I'm going to go and raise this to 45. We'll raise this to 45 as well. Notice what's happening. As we're raising the airflow, engine speed is 1,050, 1,060. We're almost at target, and notice the spark timing is a little bit less. Now the spark timing is moving around here dynamically because of this proportional and derivative type adjustment that are going on. It's looking at the target, which is coming from our table here. It's looking at the air, and it's figuring out based on the air what kind of spark timing it needs to add or subtract. So the median, or where we want the baseline to be at, is 10 degrees. It can go and take it down to 0 degrees to reduce torque, or take it up to 30 to increase the torque, and doing it in this fine adjustment manner. And it's floating around here pretty quickly. And that's pretty normal, what you'd expect behavior-wise with the ignition timing. No, we're not hitting the target yet, so we're still seeing we're about 80 RPM, 100 RPM off. If I raise this up to 50, that's going to get us even closer. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.